So this problem is pretty similar to the animation, the GIF animation I just showed you. And this is again a direct consequences and very interesting consequences of conservation of angular momentum. So here it's, and this also lab, this interesting lab actually we could easily do in the lab. So here's the thing, this student holds a spinning wheel, bicycle wheel, right? He's not spinning initially. He's just holding this spinning, is spinning in counterclockwise direction, uh, which is the bicycle wheel initially is spinning at 3.9 revolutions per second. He's just holding. Now the next it says while uh, what happened to the what would be his spinning rate as soon as he flips the bicycle wheel. So as soon as he flips the bicycle wheel, what's going to happen to his body? So, and these are the given quantities, given variables. So the main question is, what is his angular speed once he inverts the wheel in opposite direction? And this is also again in terms of, so you can study, actually you can show the vector nature of angular momentum here. So what's going to happen is, as you inverts, right, as you flips the wheel by 180 degree, since initially, so first I'm going to first show you this vector nature of the angular. So all the total angular momentum you have in the system is just the wheels, the bicycle wheels angular. This is the total angular momentum of the system, and that will not change. We know that since there's no external torque, this should remain. We know the answer. The final angular momentum of the whole system has to be constant, has to be same. And because of that, to do this, then this student's body has to, spin automatically, right? As you can see in the GIF animation previously, uh, it will rotate so that the sum of this angular momentum, this is the wheel's angular momentum, right, after he inverts it. So the sum of this two, right, must be equal to the initial. The sum of this, the vector sum of these two angular momentum has to be equal to the total initial angular momentum, right? Because we know that the total angular momentum initial and final must be equal conservation. So that's what you need to do here. So so again, let's start with the calculation part is this same. The vector sum of the angular momentum has to be equal, right, before and after he inverts the bicycle wheel. So initially the body is not rotating, so you have the angular momentum only I of the bicycle wheel and times omega initial, right, is equal to, once he inverts it, so you have now two angular momentum. One is angular momentum of the body, the student body, omega final, which we're going to calculate, we don't know that, and right, and negative, because the angular momentum of the bicycle wheel once he inverts it is negative now, in negative g direction, because now it's spinning in clockwise direction as he inverts it. So make sure you don't forget this negative sign. I of the bicycle wheel, right, times omega final. Its magnitude is same as before, only inverse the direction, and you're solving the final angular velocity of the student, right, and that's it. So I body omega final is I bicycle omega initial plus I bicycle omega final, right, and then we're solving this. So I bicycle omega initial plus I bicycle omega final divided by I body, and let's put all the numbers. So the bicycle has a moment of inertia 1.2, and omega initial wheel has 3.9. It's in revolutions per minute per second, so that's why you have to multiply by 2 pi plus the same thing 1.2. Its magnitude is same, right? Because he just inverts it. Its magnitude is same, divided by the body has moment of inertia 6.8. That's given. So that's the final angular velocity once you invert it, and you can calculate that, and from calculation you can see just gonna quickly do that. 8.64, 8.6. So we have converted this into radians per second, so this in radians per second. So that should be your answer. Okay, and you can clearly see, right, the angular velocity. You can check the magnitude. So that's your answer. So this is the angular velocity of this student body.